And number 6, to find the total distance traveled when they give you the velocity. Well, if we know that the velocity is 6t minus t squared, then the integral of this is the position function. And if we're talking about distance traveled, we need to know the position. So to find the total distance traveled, all you're really doing is just integrating 6t minus t squared from time 0 to time 3. Okay, and the integral of this is 3t squared minus 1/3 t to the third from 3 to 0. Okay, plugging these values in, you essentially get 27 minus 9, and you get 18. Choice D. For this one, they want you to find the derivative, so what I have to do is put the exponent down in front, x to the third minus cosine x down 1, but then I have to multiply by the derivative of what's inside. The derivative of what's inside is 3x squared minus a negative sine x. So I have 5x to the third minus cosine x to the fourth times 3x squared plus sine x. This would be choice E. For number 8, they give you a situation here about oil being pumped out. I graphed all of my values, and they want you to use a right Riemann sum with 3 subintervals. So basically what you're doing is to do a right one, you're going up, or excuse me, you're going up, over and down, you're going up, over and down, and you're starting from the rightmost one, going up, over and down. What I did by accident, I started doing a left one by accident. My apologies. So to find the area of these 3 rectangles, I know that this is 3 and this height is 6.2, this is 5 and this is 5.9, this is 3 and this is 5.6. So I'm going to do 3 times 6.2, and I'm going to add that to 5 times 5.9, and I'm going to add that to 3 times 5.6. Now there's a piece of information here that some of us probably overlooked, was the fact that it says that a tank contains 50 liters of oil already at time 4. So what I have to take into consideration is all of this, and then I have to add 50 to get my answer of 114.9, and then this is choice C. For number 9, this is essentially the definition of continuity, and what I'm looking at is that I took that first part of this piecewise function, and then I pretty much just canceled these 2 parts, and I graphed the line y equals 2x plus 1. Well, they're telling you that it can't be this function for x equals 2. There's going to be this hole, this removable discontinuity. So basically they're asking, what is this y value? What is the y value here? So for this piecewise, you have to have 2x plus 1 and x minus 2 over x minus 2. Okay, but then this k has got to be 1, 2, 3, 4, 5. So this is choice E. For number 10, they want to know where is this graph, to find the area of the region by the first quadrant, basically from the y-axis to this line x equals 2. Now this is a non-calculator question, so you're probably asking yourself, how are you supposed to do it? Well, when x equals 0, e to the 0 over 2 is the same as e to the 0 or 1. Notice I plotted my x equals 2 vertical line. I know e to the x is an exponential function, so e to the 0 is at 1. But when x equals 2, that basically means e to the 2 over 2, or e to the 1, or just e. So this point right here is basically 2e. Regardless, to find the area, what I'm going to do is the integral from 0 to 2, and I'm going to say e to the x over 2 dx. So to integrate this, what I'll do is I'll let u equal x over 2, or 1/2 x. Remember, deriving it just gives me 1/2 du equals 1/2 dx. So what I have is 0 to 2 e to the u du. But remember, in order to make that substitution, you have to do 1/2 here, and then you have to put a 2 outside. So I really have this.